Okay, guys, welcome back. Thank you for your patience today as I struggled through my little power outage situation. I did want to finish up the notes and talking about reactions. So let's start here with, and I don't think we get to this in class today, but the anatomy of a chemical equation. When you look at a chemical equation, what does it all mean? So the first step is going to be to recognize what we have shown on the left versus the right. On the left, we refer to the substances that go into the reaction as reactants. And on the right, we call these products. So what gets made. So that's a bit of important terminology. And then when you see the arrow, the way you read that is either yields or you would say produces. And then the final part here is the G, which in this case, stands for gas. That's your physical state. And that could be G for gas, L for liquid, S for solid, and AQ for aqueous. And aqueous just means dissolved in water. Okay, so if you had salt water, it'd be NaClAQ. Okay, so that's just kind of what the chemical equation, the parts of the chemical equation are. So for example, you might look at this and describe this as CH4 carbon tetrahydride gas reacts with oxygen gas to produce carbon dioxide gas and water vapor or water gas. Also, the one thing I've almost forgot to mention here is the coefficients. So coefficients refer to the number of molecules or moles of each type. So this would be one CH4 molecule reacting with two oxygen molecules to produce one CO2 molecule and two water molecules. Or if we wanted to talk in larger amounts, more tangible amounts, you could say 1 mole of CH4 reacts with 2 moles of oxygen, etc. Okay. The next thing we want to talk about is balancing equations. And of course, you're going to want to pause and write these rules and tips down. Okay, so let's go ahead and put these into play, kind of get started using some of these. Let's start with an example, and hopefully it will make the rules and tips a little bit clearer as we go. So first example here is Mg plus O2 yields MgO, magnesium oxide. So to balance, we cannot change subscripts. All right, that's rule number 2. We must get the number of atoms of each element equal on the two sides. So if I have 1 magnesium on the left, I have to have 1 magnesium on the right, which is true for this one. If I have 2 oxygens on the left, I have to have 2 oxygens on the right, which is not true. So oxygen needs to be balanced. So according to the second rule, I can't change subscripts. And the reason for that is if I were to put a 2 here after oxygen, I'd be changing the ratio of magnesium to oxygen in magnesium oxide, which is based on the bonding that those two do. And so you can't just change the ratio. The only thing you can do, which is what we will do, is say that we have 2 formula units. It's kind of like saying 2 molecules, only for ionic compounds in this case. 2 formula units of magnesium oxide are produced instead of just 1. But that 2 coefficient goes for the whole thing. Unlike a subscript, which only goes for one element or one particle, the coefficient on in front goes for the whole thing, the whole formula. And so that means I also have 2 magnesiums, which would mean I need to put a 2 in front of magnesium. Again, I don't balance with subscripts. That would suggest that there is such a thing as a molecule of Mg2, which is not true. All right, we only balance with coefficients. Okay, let's try another example. This one we're going to do C5H10 plus O2, once again, gives us CO2 plus H2O. We're going to actually use 2 different tips in this one. One of them is that we're going to balance the lone element last. And in this case, that's oxygen. So oxygen is the only lone element. Up here we had magnesium and oxygen that were both showing up as elements on the left-hand side. In this case, oxygen is the only thing that shows up as an element. All three of the other substances are compounds. We're going to save oxygen for last because it's going to make things less complicated. Because by putting a coefficient in front of oxygen, we're only changing oxygen. If I put a coefficient in front of C5H10, and I think that's going to be my last step, the problem is I'm not only changing the carbon, I'm also changing the hydrogen, and so then I might have to come over here and put something onto water, and it just goes back and forth endlessly. So we want to save that oxygen for last because it's the lone element. The other tip is number 3, fractional coefficients can be used temporarily. So I'll get to that in just a second. Let's start balancing. We're going to save oxygen for last. So let's just arbitrarily pick, let's go with, let's do carbon first. Doesn't really matter. So 5 carbons because I have 5 on the left. Okay. Then if I look at hydrogen, I've got 10 on the left, 2 on the right. So I'm probably going to go with the least common multiple of 10. So by putting a 5 in front of H2O, that gives me 10 hydrogens. And then I have that would match my 10 hydrogens on the left. So now I look at my oxygens. So I'm going to go ahead and say, all right, I've got 10 oxygens here, plus another 5 here, okay? And so that's going to give me 15, which is an odd number. And the reason that's significant is because this 2, if I'm going to multiply by 2 to get to 15, to match the 15 that I have on the left, right? So I had to add up the 10 oxygens that are here plus the 5 that are here, that's 15. So the only thing that I can multiply by 2 to get 15 is 7.5. But I just said that the coefficient stands for the number of molecules. And I can't have 7.5 molecules. That doesn't make sense. So I can use it temporarily, as the tip up here says. And then what I'm going to do is go through to get rid of that temporary decimal or fraction. I'm going to multiply it by 2. But if I'm going to multiply it by 2 to get a whole number, I've got to multiply everything by 2 because otherwise the equation will never be balanced. So 1 becomes 2, 5 becomes 10, and 5 becomes 10. And just to make sure that I've got this right, I'm going to go through and do the math. So for this carbon, I've got 2 times 5, which is 10, which matches the 10 I have on the right. Remember that the 2 on the CO2 only goes for the oxygen. So I have 10 carbons because of the coefficient. As far as hydrogen is concerned, I've got 20, and over here I've got 10 times 2, which is also 20. Oxygen-wise, I've got on the left 2 times 15, which is 30. On the right, I have 2 times 10, which is 20, plus 10 times 1, which is 10, so that's 30, and everything matches up. Also, the last rule up here, coefficients must be reduced. So I've got 2, 15, 10, and 10 as my ratio, and that is in fact reduced. Okay, let's try another here. So this will be our third example problem. Okay, so we are going to do AlPO4, aluminum phosphate, is going to react with calcium. It's going to give us calcium phosphate, which would be Ca3PO42, and aluminum. Okay, so this has 2 lone elements, so saving the lone elements for last doesn't really seem to be a helpful tip in this one. But we do have a polyatomic ion that shows up on both sides of the equation. We have phosphate on the left, and we have phosphate on the right. So what we want to do here is to balance this equation. You could balance phosphorus and oxygen as separate elements, and that would be fine, that would work. But it would probably take you a little bit longer and be a little bit more confusing. So what I would recommend is anytime we have polyatomic ions, we're going to balance them as entire ions instead of individually balancing their elements, in this case phosphorus and oxygen. So in other words, very simply, all I'm saying is if I have 2 phosphates, meaning 2 PO4s on the right, I need to have 2 PO4s on the left. And it looks like I currently do not. I only have 1 PO4, right? You can kind of imagine parentheses around this PO4, but there's nothing outside of the parentheses, so there's only 1 of them. I'm going to go ahead and have to put a 2 out in front to balance my phosphates. So that also gives me 2 aluminums. So I'm going to come over here and put a 2 there. And then the last step, it looks like calcium is still not balanced. I've got 3 on the left, so I need to have a 3 on the right. Once again, that has to be done as a coefficient. And since a 2 to 3 to 1 to 2 ratio can't be reduced, we're done. Okay, last example. We are going to do, and that's going to be CO2, or I'm sorry, CO2O3, meaning cobalt 3 oxide. So that's cobalt with a 3 plus charge paired with oxide. And that's going to react with dinitrogen trioxide. And that's going to give us cobalt 3 nitrite. And you guys will learn how to predict these later on. But for right now, I'm giving you the entire equation. So the reason I wanted to show you this example is because here we have a polyatomic ion nitrite on the right, but we don't have the same polyatomic ion nitrite on the left. We really don't have any polyatomic ions on the left. So we're going to have to break it up and balance it as, separately as nitrogen and oxygen. So we can't use tip number 2 on this problem because the polyatomic ion only shows up on one side of the equation. Okay, so let's take a look here. Let's balance cobalt maybe. Do cobalt first, and the order doesn't really matter. I'm just kind of guessing at this point and trying to see what works. So to balance cobalt, it looks like I need a 2 right out in front. Now that makes everything multiplied by 2. Okay, so I've got 2 cobalts. That's awesome. But let's see how many nitrogens I have. So originally with 3 nitrites, that would have given me 3 nitrogens. But then I have to multiply that by 2 because I have that coefficient 2. So I actually have 6 nitrogens. So what am I going to have to put out in front of N2O3? I'm going to have to put a 3 so that I have 6 nitrogens on each side. So I have 6 nitrogens now, and that matches my 6 nitrogens. And let's see if our oxygens work out. I have 3 times 2, I have to distribute the 3 into the parentheses. So that's going to be 6 times the 2 out in front, so that's 12. And then on the left, if I do 3 times 3 here, that's 9, plus that 3 with no coefficient, or a coefficient of 1. So 9 plus 3 would be 12 also. So this one is balanced with just the 3 and the 2. Now in class, I think I told you I was going to go ahead and give you a reading assignment in addition to finishing up the notes. I think instead what I'm going to do is give you a little bit more practice with balancing equations and writing them, but I'm going to guide you through them. And so there will be a worksheet in Schoology if you haven't seen it already, but we're going to do the first couple together, whereas my second hour, we'll just have to do them on their own because they had the entire 55-minute class, so we got cut short. So we'll do a couple together here. Okay, so this is what the worksheet looks like. I want you to write the chemical equations and then balance them. Okay, let me move myself out of the way there. So number 1, solid potassium reacts with aqueous cobalt 3 chloride to produce aqueous potassium chloride and solid cobalt. All right, so if we got solid potassium, that's just going to be K solid. Aqueous cobalt 3 chloride is CO, Cl3 aqueous. And the physical states aren't going to affect our balancing at all. That's just something you need to get in the habit of doing whenever the information is provided. And notice I put the 3 on the chloride because it was cobalt with a 3 plus charge. Chloride only has a 1 minus charge. Okay, so it's going to produce potassium chloride, which would just be KCl because it's plus 1 and minus 1. And that is also aqueous. And solid cobalt. So CO, S for solid. Now to balance this one, it looks like we've got 3 chlorides on the left. That's the only thing that's really out of balance right now. So I'm going to put a 3 out in front of KCl. Again, we cannot add a subscript. We also can't put a coefficient in the middle of the compound because that would also change the ratio. That would essentially be like a subscript. Got to keep that 1-to-1 ratio, but what we can do is say that we have 3 of the entire molecule, or in this case, formula unit. So that gives me 3 potassiums as well, though. So I will have to put a 3 out in front there. Cobalt's already balanced to 1-to-1, so we should be good. Okay, let's try another one. Aqueous silver sulfate. So silver is Ag plus 1. Sulfate is SO4. Oops, I don't actually need this parentheses. So sulfate is SO4 2 minus. So I'm going to need 2 silvers. Again, that's aqueous. It's going to react with barium metal. Now, it says barium metal. Most metals are solids at room temperature, so I'm going to assume that barium is as well, and of course it is. And it's going to produce solid silver and aqueous barium sulfate. So barium is plus 2, sulfate is minus 2. So 1-to-1 is good. But it does say aqueous, so whenever it says that, we want to include it. Okay, it looks like we've got 2 silvers on the left and only 1 on the right, but everything else, it looks like, is already balanced. 1 sulfate, 1 sulfate. Remember to balance that as one thing. 1 barium, 1 barium. Okay? All right, let's do one more of these word equations, and I think you guys should be good to go on the rest of the assignment. Okay, so we've got dicarbon hexahydride, so C2H6 gas is burned, meaning it reacts with oxygen. Now, oxygen is diatomic, so that means that it comes in 2s when it's pure. All right, just like all the halogens, we talked about that earlier. It's going to produce gaseous carbon dioxide, so CO2 gas, plus water vapor. Vapor is just another way of saying gas, right? So H2O gas. Save oxygen for last because it's alone. So maybe we want to balance carbon first. Put 2 there. And then hydrogen, we've got 6. So over here we've got 2. So we're going to want to put a 3 out in front. So that would give us 6 on both sides. Now oxygen on the right, I have 2 times 2 is 4. Plus 3 is 7. So if I have 7 on the right and then 2 on the left, 7 times what would give me, 2 times what would give me 7? Right, so you should have said, I'm going to have to squeeze it in here, 3.5. But of course that is a fraction, a decimal, not a whole number. So we're going to have to multiply it by 2. And if we can't do that without multiplying everything by 2. And there you go. So go ahead and finish up. There's 10 problems total. They're not all word equations. That'll be found in the Schoology Week 8 folder. But hopefully with the help of these notes and doing the first 3 of them together, you guys can do well on 4 through 10. So make sure you come to class with questions, and we will see you guys tomorrow.